Welcome to the CFA Level 1 presentation on time value of money. In this presentation, we look at what is meant by an ordinary annuity. We then learn how to compute the present value and future value of an ordinary annuity. And finally, we learn how to use a financial calculator to perform these calculations. Before we start discussing what's meant by an ordinary annuity, we should know what is meant by the word annuity. An annuity represents a finite series of equal cash flows over equal time intervals. For example, this timeline here represents an annuity. It has a finite series of cash flows. If these cash flows were to go forever, we will have what's called a perpetuity, which is a slightly different concept. Now, these cash flows are obviously of equal amounts, and also they occur over equal time intervals, which is after every single period. That is why this timeline represents an annuity. Now, what's an ordinary annuity? An ordinary annuity is an annuity in which the first cash flow occurs in one period from now. If we go back to this timeline, this represents an ordinary annuity because the first cash flow of $100 occurs in one period from now at time t equal to 1. We are currently at time t equal to 0, which represents today. If the first cash flow were to occur at time t equal to 0, we will have something called an annuity due, which is also a somewhat different concept. On this slide, we will compute the future value of an ordinary annuity using a timeline to get a better sense of how these calculations work. On the next slide, we will use a financial calculator to perform these calculations much faster. So let's compute the future value of an ordinary annuity with 3 annual payments of $1,000 and an interest rate of 5%. So we have drawn this timeline and we are at time t equal to 0, which is today. We go to time t equal to 1 and we look at the first payment of $1,000 and we compound it from time t equal to 1 to time t equal to 3, which represents 2 time periods. Therefore, we just take this $1,000 and compound it by multiplying it by 1.05, which is the interest rate, to the power of 2, which represents 2 time periods. And we get this number. We then move to the second time period and we compound the $1,000 payment from time t equal to 2 to time t equal to 3. Again, we multiply that by 1.05 to the power of 1, which is 1 time period, and we get this amount. And finally, for the third payment at time t equal to 3, we don't need to compound because that's the final payment. So we just have 0 in the exponent and we get $1,000. And the total future value of this ordinary annuity is $3,152.50. Now we can do the same problem using a financial calculator and we can do it much faster. In order to do so, we first need to get the calculator to its standard mode and to remove the memory of any prior calculations. We do that by first hitting the button second and then pressing this button to quit, and that brings us to the standard mode. We then clear the memory by hitting this button second and clearing the time value of money. And now your calculator should display 0 on its screen. To perform the time value of money calculations, we will be concerned with these keys here. We start entering the payment by hitting 1000 and pressing the button PMT. Your screen will display this. We then enter the periods 3 and then N. We enter the interest rate as 5 and this button I/Y, and then we hit compute, and then we hit FV or future value, and then your calculator should display this figure. You would notice that this is a negative amount, whereas your payment was positive, and that will always be the case. The future value or present value would always have a sign which will be opposite to the payment sign. The other thing to notice is that you don't need to enter these amounts in this particular order. If you want, you can first enter periods and then interest rate and then payment. You can choose any order you want, but as long as you enter this information, you will be able to compute your future value. And you can verify that this number that we got here is exactly the same as we got on the previous slide right here. Now let's compute the present value of an ordinary annuity with 3 annual payments of $1,000 each and an interest rate of 5%. Again, we'll start with a timeline on this slide and use a financial calculator on the next slide. We have this timeline here. We are at time t equal to 0. To compute present value, we go to the next period, which is t equals 1. We take that $1,000 payment and we discount it to the present by dividing it by 1.05 to the power of 1. We move on to the next time period, t equals 2. We take that payment of 1,000. Again, we discount it back to 2 periods and we get this figure. And then finally we go to time t equals 3, which is 3 periods from now. We take that payment of $1,000, discount it to the present by using 3 in the exponent here, and we get this figure. And then if you take the sum of these 3, you will get a total present value of 2723.25. Now let's try our financial calculator for the same problem. Just as we did earlier, we will have to return the calculator to its standard mode and clear memory for any calculations we did previously. We hit second and quit to return the calculator to the standard mode. We clear the memory by hitting second and clear time value of money. Your calculator should display this. We entered these 3 figures. So payment is 1000 PMT, 3N is period, 5 interest is your interest rate, and then we compute present value by hitting second and present value, and you get this figure, 2723.25 negative. Again, notice that this is a negative amount as opposed to your PMT, which was positive. You can verify that this amount that we got for present value is the same as what we got earlier right here. Also, as we said earlier, you can enter these 3 amounts in any order you like. You will still get your present value. Now this brings us to an end to this presentation. If you found the video useful, please make sure to like it and to subscribe to our channel. Thanks very much for watching, and we wish you the best of luck on the exam. Thank you.